Hi everyone, we're going to review over 6.1 to 6.4 for our quiz tomorrow. Please remember that you are expected to take your quiz during your scheduled geometry period, and if you don't know when that is, just take a look at our WAG. Number 1, if two polygons are similar, then their corresponding angles must be A, complementary, B, supplementary, C, congruent, or D, a linear pair. The answer here is C, congruent. So all the corresponding angles must be the same measure. 2, if two polygons are similar, then their corresponding sides must be A, proportional, B, congruent, C, parallel, or D, similar. The answer here is proportional, A. So just remember that the scale factors must be the same throughout the polygon. 3, the triangles below are similar. Find X. If I look at X here, it's in the large triangle. So now I need to look at my triangle and figure out two sides that are corresponding that I do know the side lengths of, and we'll focus on 39 and 6. So let's write a ratio using 39 and 6. It does not matter which is in the numerator and which is in the denominator. You'll get the same answer. So 39 over 6 is equal to, now what does matter is where you put the x value. Now the x is with the large triangle, so it means it needs to go in the numerator because we started with the large triangle with 39. Divided by, and what side corresponds with x? Well, it would be 19. So now to solve for x, I'm just going to cross multiply. So 6 times x is 6x. 39 times 19, that will give me 741, meaning that x then is going to equal 123.5. Number 4, triangle ABC and triangle EFG are similar, with the measure of angle A equals to the measure of angle E, and the measure of angle B equal to the measure of angle F. If AB is equal to 3 inches, BC is equal to 5 inches, and AC is equal to 6 inches, and EF is equal to 4.3 inches, we want to find the length of EG. Now, I don't have a picture here, and I don't know about you, but I am a visual person, so I need to see what's going on. So I'm going to pause the video for a second. I'm going to draw out this situation. So here is my diagram. So I want to solve for x, which is the length of EG here. So once again, my first step is I need to look at two sides that correspond that I do know the side lengths of, and that would be 3 and 4.3. So I just need to write out a ratio. So 3 over 4.3. Now, which side does x correspond to? Well, that would be 6, and 6 is in the first triangle, which means it's going to be in the numerator here. Divide this by x. And so now I need to cross multiply. 3 times x is 3x. 4.3 times 6, that gives me 25.8. Divide by 3 on each side. So 25.8 divided by 3 gives me 8.6. Question 5 here. We are given that triangle ABC and triangle DEF are similar. We need to solve for x and y. Let's start with x. So x is here. It corresponds with side 18. And then the two sides that I do know of for both triangles would be 10 and 6. So let's draw out this situation then. So I'll just do 10 divided by 6 equals, we have to use 18 first here, 18 over x. 10 times x is 10x. 6 times 18 is 108. So then x then is equal to 10.8. All right, let's solve for y. Now y, I'll box it, is here. That corresponds with 9. So I'm going to use my first fraction here again to find y. So 10 over 6 is equal to, now y has to be in the numerator this time because that is with this triangle. So y over 9, cross multiply, 6y is equal to 90. So that is 10 times 9. Divide by 6y is equal to 15. The perimeter of triangle PQR is 112. PQ is equal to 42. The triangle PQR is similar to triangle STU, and we know that ST is equal to 36. What is the perimeter of triangle STU? Once again, I want to have a picture here so I can see exactly what this problem is talking about. So I'm going to pause the video and draw this out. So here's my situation. So I want to figure out what is X, the perimeter of triangle STU. If I do look at these two triangles, I know these sides. So I'm going to write a proportion here. So I will use 42 over 36. Now remember that the ratio or scale factor for our corresponding sides will be the same for our perimeter. So if I know the scale factor for the sides, that's going to work as well with the perimeter. All right, so 42 over 36 is equal to, well, the perimeter of this large triangle is 112, so that's going to go in the numerator, divided by, I do not know what this perimeter is, and that will be x. So from here, I'm going to cross multiply. 42 times x is 42x is equal to 36 times 112. That's going to give me 4,032. Divide by 42 on each side. You end up getting that x is equal to 96, meaning that the perimeter of triangle STU is equal to 46. Or I'm sorry, is equal to 96. Number 7, a photo needs to be enlarged from an original with a length of 7 inches and a width of 5 inches to the size where the new width is 15 inches. What is the new length? All right, so once again, I'm going to draw this out. So I have a picture and we have a length of 7 and a width of 5. So width here, length here. And then in my new picture, draw a very bad rectangle. I know that my width is 15. I need to figure out what is the length here, x. So let's write our proportion. We know 15, or I'm sorry, we know 5 and 15. So 15 over 5. And I could flip this around. It doesn't matter the way you write this fraction. What does matter is what comes next. So 15 was in this rectangle, which means x needs to be in the numerator. Divide this by 7. Cross multiply. So 5 times x is 5x is equal to 15 times 7 is 107. 105. Divide by 5 on each side, I end up getting that x is equal to 21. So this length here is then equal to 21. Well, what is the scale factor? Well, remember we're going from the small rectangle to the large rectangle. So our scale factor needs to be greater than 1. So I could actually do this division problem, 15 divided by 5, and you end up getting that the scale factor is equal to 3. And you can double check that because 5 times 3 is equal to 15 and 7 times 3 is equal to 21. They should match up. Question 8. Let's remember that K just means scale factor. So if your scale factor is greater than 1, then your dilation is going to be an enlargement. Your figure is going to get larger, just like in the example for number 7. If your scale factor is less than 1, then the dilation is going to be a reduction, meaning that it's going to get smaller. For question 9, we want to know, are these two triangles similar? Explain. Remember, our explanation should be the angle-angle similarity theorem, angle-side-angle similarity theorem, or the side-side-side similarity theorem. And if they are similar, what's the scale factor? So let's look at these, the first 2 examples here. So I have triangle WPY and triangle ZDN. We see that they're not in the same position. You kind of have to flip that smaller triangle around. And let's start by looking at our sides. So let's start with the shortest side here, which is 30, and the shortest side of the smallest triangle, which is 9. So now what I'm going to do is I'm going to write a fraction out. So I'll do 9 over 30. This simplifies. They're both divisible by 3, and so that would be 3/10. So that's my scale factor for the first side. Now let's compare the 2 other sides. So I have 12 and 36. So 12, divide that by 36. And this simplifies to 1/3. So are these 2 fractions the same? They're not, meaning that their scale factors don't correspond. So no, these 2 triangles are not similar. Let's look at our next 2 triangles here. So once again, they're not in the same position, but I can kind of look at the smallest side first and move up. So the smallest side on this triangle is 20. The smallest side on this triangle is 25. So let's write our ratio. I'll start with the 20 on top. So 20 out of 25. And we're going to simplify that fraction, and we get 4/5. Let's move on to the next side. So the next largest would be 28 here. The next largest would be 35 here. So if I write out that ratio, 28 over 35. And this simplifies to 4/5. So far, so good. Those fractions are the same, but I do need to check that third side. So I'm going to compare these 2 now. And so 32 over 40. And that is also equal to 4/5. So yes, these are similar. Which theorem is this? It's the side, side, side. I only know my sides, and I know that all 3 are proportional. For the third triangle here, I do know this angle and this angle. And I do know my one side is 22, one side is 20. But that's not enough information to prove that these 2 triangles are similar. But what I do know is that I have a pair of vertical angles, and I don't know exactly what they are, but I do know that these are congruent. So now I do have enough information to prove that these 2 triangles are similar. So yes, they are similar by side, side, side. But I do need to figure out what the scale factor is, and that's why those 2 sides come in handy here. So I'm going to do, it doesn't matter which one's first, we'll do 20 over 22. This simplifies to 10 over 11, and that would be my scale factor then. Late in the afternoon, a man who is 6 feet tall casts a 15-foot shadow. He is not far from a tower that is 68 feet tall. How long in feet is the shadow of the tower? All right, I'm going to draw this situation out. So here is my diagram. So this is going to represent our man, and this is going to represent the tower. So I need to solve for x. All right, and my first step is to compare the two sides that I do know, which is 6 and 68. So 6 over 68 is equal to, 15 needs to go in the numerator, 15 over x. Let's cross multiply, so 6 times x is 6x is equal to 68 times 15. That is 1020. Divide by 6. So x then is equal to 170, which means that the tower is going to cast a 170-foot shadow. Number 11, Moody wants to find the height of the tallest building in his city. He stands 422 feet away from the building, and there's a tree 40 feet in front of him, which he knows is 22 feet tall. How tall is the building? So I just kind of labeled everything that we knew, that the man that's standing here is 40 feet from a tree. The tree is 22 feet tall, but he's also standing 422 feet away from the building. What is the height of the building? So we technically have two triangles here. I have a triangle here, and then the large triangle. So when I set up my proportion, let's start with the length of each triangle. So I will do 40 over 422. That is equal to, and then we'll do the height. So 22 over x. Then I'm going to cross multiply. That becomes 40x is equal to 422 times 22. That is 9,284. Divide by 40. You end up getting that x is approximately 232.1, and it did say to round to the nearest foot, so since it's 0.1, I'm going to keep it as 232, so 232 feet. All right, for number 12, are the two triangles similar? If so, explain. And then if they are similar, what transformations can be used to get the dotted figure onto the solid figure? All right, so with our first example here, I noticed that these angles are congruent. So now I need to kind of compare my sides and see if my fractions are the same. And right away, we can kind of see that these are not going to be similar. Here I have 5 and 5. So if I divide those, 5 over 5, that means that my scale factor is equal to 1. My other ratio would be 12 over 4. 12 over 4 is not equal to 1. It's equal to 3. So those are not the same. So right away, no, they are not similar. Looking at my next example here, I do see I have an angle here and an angle here. I have an angle here and an angle here. So right away, these are similar because of the angle-angle theorem. So yes, they are similar because of angle-angle. Now I need to figure out what is the scale factor. So my scale factor, I'm going to use, it doesn't matter which one, so I'll just write scale factor. (13 over 5). So part B, if they are similar, what transformations could be used to map the dotted figure to the solid? So this scale factor is the only one that would work, because if you look, the dotted one to become the large triangle, we need a scale factor larger than 1. And if we do 13 divided by 5, you get 2.6. So that is my scale factor. So how do I get this triangle onto this triangle? Well, you'd have a dilation. And I'll just put 2.6 of 2.6. And then after this triangle gets larger, it's going to flip, which is a reflection. For the third example here, I do have some side lengths, so I just need to compare the side lengths to determine, are they proportional. So let's start with the shortest side length, which is this one and this one. And I don't really need to find my scale factor. I mean, I don't have to write a proportion. It goes from 5 to 10 or 10 to 5. So we are, remember it says the dotted to the solid. So dotted is larger, going to the smaller. So that would be 5 over 10, which is equal to 1/2. Let's see if that works for all these. So the next one would be 12 and 6. That's also 1/2. And then 14 to 7, that would also be 1/2. So yes, these are similar. And we can say side, side, side. I do have vertical angles here. So I would also accept side angle side if you noticed right away that those are vertical angles. Next, it asks what transformation occurred. Well, we know a dilation because it's getting smaller. So dilation. Now, if we're getting smaller and then it's rotating, if we focus on this 14 and 7, it couldn't be a reflection because 6 is over here when we wouldn't need 7. So it would have to be a rotation, because it's rotating around and that our new length is over here. So rotation. In our last example here, are they similar? I mean, you can kind of look at this and tell that these are not similar, but let's prove why. So 16 and 16, those are going to match up here, and that would equal 1. But if we do 10 and 25, we would not get a scale factor of 1, so no, these are not similar. And that's it. If you have any questions about the study guide, just send me an email and make sure you study.